All right, so we're going to talk about naming binary molecules. Binary means how many? Two. Okay, so we're talking about two things put together. So we're going to name binary molecules. Remember, molecules is focusing on covalent bonds, atoms that share electrons, and we're looking at mostly nonmetals. All right, so what you do is you name the first element, then you change the ending of the second element to IDE. That was no different than what we did with ionic binary compounds. But we have to add an element here. We have to add prefixes to this, and I need you to memorize those prefixes. Okay? Yes, you need to memorize those prefixes. But if you had me in 8th grade, you did it then. So it's there. You just gotta pull it out, okay? It's there. All right, so I want you to memorize those prefixes. The only exception to the rules of using the prefixes is you're not going to use mono on the first element name. But the best way to learn how to do this is to just jump in and practice, I think. I could read these rules to you all day long, and until we apply them, it's going to be hard to actually see what we're doing, okay? But always keep the rules handy to refer to them. So let's do a little practice, and I've written these out. So if you don't have your book, it's okay. I've got them written out. All right, so let's look at the first one. We have CO2. Now, you might want your prefixes in front of you from your notes. We all know what CO2 is, right? What is CO2? Carbon dioxide. You've seen this since the 7th grade. All right? But the rules say, I have to use the prefixes. The rules say that the prefix for one is mono. But my exception in the rules is I can't use mono on the first element. So that's why it's not monocarbon dioxide. It's just carbon. And then I have two oxygens, so I've got to use that prefix di or dioxide. That's it. I just changed the ending to IDE. I added my prefix. I didn't need a prefix on carbon. So carbon dioxide. I'm done with that one. All right, what would number 15 be? Sulfur dioxide. Same concept. I can't use mono on the first one, so I'm going to write sulfur. There's two oxygens, so I need the prefix di, and it's a binary molecule, so I changed the ending to IDE, dioxide. That's it. Jacob, can you say it again? Make sure everybody hears. What is number 16 here? Nitrogen. Again, we don't use the prefix mono. Prefix for 3, there's 3 fluorine. So the prefix for 3 is tri. You should know that. Y'all had a tricycle, right, with 3 wheels. Trifluoride. Same as a triangle with 3 sides. Yes.
Is this binary molecules?
Yes, these are binary because there's 2 elements. All right, 17. What'd you think, Caleb? Close. Carbon. Prefix for 4 is tetra. So carbon tetrachloride. Carbon tetrachloride. Any questions on these first 4? It's pretty straightforward once you get into the practice of it. Memorizing your prefixes will help you. All right, diarsenic. So how many arsenic do I have? I have 2. All right, so arsenic is As2. Trioxide. What element is that?
Oxygen.
That's oxygen, and how many oxygen do I have? 3. So that's just turning it around and doing it backwards. Any questions? No? Okay. Let's move on in the PowerPoint then. All right, so that's binary molecules, just 2 elements. Now, you know things can't stay simple. We're going to complicate it just a little bit. Okay, there's our prefixes. Oh, let's see. So now we're going to get into naming, that's binary molecules, naming acids, okay? So you've heard of acids. You know you have stomach acid, which is hydrochloric acid. You've heard of sulfuric acid. But why would I call one in my stomach hydro something, and then another one is sulfuric with no hydro in front of it? You hear all these different names for acids. There's rules for those too. So that's what we're going to get into. If I have a binary acid, that's going to contain hydrogen and one other element. If I have an oxyacid, it's going to contain hydrogen and an oxyanion. What did an oxyanion have to have in it to be considered oxygen? Okay, so you're going to see oxygen in this. And where do you think these oxyanions are going to come from? Like, what are parts of it going to come from? This handy dandy little polyatomic ion chart. Okay, so you're going to need to make sure that you still have this chart for figuring out the names of these acids. Okay, now here's all these rules. Let's see, that's binary acids and oxyacids. Now we're going to go through these rules, but you're going to want them beside you when you're trying to go through and name these things. Like I said, practice is what teaches you how to do this, not necessarily me talking to you and telling you. So if I have a binary acid, I'm going to use the prefix hydro in the name. So like I said earlier, hydrochloric acid that's in your stomach, that word hydro's telling me that, okay, there's only 2 elements in that acid. We're going to change the ending of the word to IC, hydrochloric, and then put acid at the end of it. Again, there's an exception here. We'll get into the exceptions a little bit later. We're not going to do those right now. I just want to put the basics out there in front of you. If I have an oxyacid, I am going to look at the root of the anion. What was an anion?
Negative ion.
A negative ion, okay? So anion is a negative ion. All of your acids are going to have hydrogen in there. So hydrogen is going to be your positive ion. It's the cation, okay? So you're going to have hydrogen as the positive, and you're going to have some kind of anion there. If the anion ends in 8, you're changing the suffix to IC. What do I mean by that? If you look on your polyatomic chart, you're going to see sulfate, chlorate, carbonate, phosphate. So if you have one of those in your acid, you're going to change the ending to IC to name your acid. If the anion ends in ite, such as chlorite, bromite, iodite, nitrite, you're going to change the ending to OUS. Okay? Now that's a lot of information just to hear. Let's practice it. All right, so we're going to go in our book and we're going to do page 251. Let's start with 19 through 24. And if you just want to, I've got them written down, so if you don't want to get your book out, that's fine. I will say, get out your polyatomic chart, though. That will help you if you get out your polyatomic chart. Do what? No, this is just practicing together, where I'm just teaching you how to do this. but it will help you to have your chart. Okay. So the first question to ask yourself is binary acid or oxy acid? Is that binary or oxy? Binary, there's two. Alright, since it's binary, I know that I'm going to put the prefix hydro at the front. What's got to be at the end? According to your rules, what suffix has to be at the end? Okay, IDE, if it's two elements, that's not an acid, but this is starting with hydrogen, so this one's going to be an acid. So hydro, what is this element here? Iodine. I'm going to call this one hydroiodic acid. Hydroiodic acid. Now, is this going to be a binary acid, or is that going to be an oxy acid? That one is going to be an oxy acid. So, am I going to have hydro at the front? No. Okay, it's an oxy acid, so there's no hydro at the front. If I have ClO3, I know I need to find that on my chart. So, I find ClO3, and that is chlorate. Now, I'm not naming the acid. I'm just writing that for me to reference. Okay? If my suffix is ATE, what do the notes say to change that ending to? The notes say to change that, the rules say change that to IC. So the way I would name that is I would just say chloric acid. But because that's not binary, I'm not adding the hydro. I just took that chlorate, changed that 8 to IC, and named it chloric acid. Questions? It's going to be very important while you're learning to do this. You have those rules in front of you. Okay? So I'm going to look at ClO2. I know I've got this H here, but I want to look at ClO2. ClO2, and if I look at that in my chart, I find that that is chlorite. Okay? And if I look, that's chlorite. So what does it say I need to change the suffix ITE to? OUS. And so now I'm going to name my acid chlorous acid. So I changed that ITE ending to an OUS. Again, it's not binary, so I don't need that prefix hydro. I'm only going to use that prefix hydro if it's a binary acid. All right, with H2SO4, binary or an oxy acid? Oxy. One, I see oxygen. Two, it's more than one element. So if I look for SO4 on my chart, it is sulfate. And since it is sulfate, I'm going to change my ending. I've got sulfate. So what am I going to change my ending to? IC. And so I'm actually going to name this one, the way it changes is sulfuric acid. Sulfuric acid. All right, 23, binary or oxyacid? Binary, there's two. So what's gonna go at the beginning of this one? Hydro. I know automatically. Hydro, what is that element? Sulfur. So hydro, sulfuric, I gotta end up binary with an IC, hydrosulfuric acid. So you can see the difference here between sulfuric acid and hydrosulfuric acid. All right, so now we're going backwards with this next one, is periodic acid. So we have the name, and does it have a hydro in front of it? No, so we know it's not a binary acid, it's an oxyacid. So if it's IC, what was the ending before if it's IC now? ATE, if we're working backwards. And if we look on our chart, we see a periodate. We see that periodicate's formula is IO4, and we see that periodicate's charge is a -1. Those are all important. We got to know the formulas for them. We have to know the charges if we're going to be able to write the complete formula. Now, every acid is going to have what element at the beginning? Hydrogen. All of these have hydrogen. What is hydrogen's oxidation number? +1. It's +1. So I know I've got an H, and I know that it is +1. Does that +1 and -1, do they balance? Yes. So when I'm putting these oxyacids together, I'm going to have one H and one periodate. So the formula for periodic acid is HiO4. I've just got one of each. Questions? All right. Let's skip to the next few. We're going to start with 26. I've just got formulas here, and I'm going to write I've got names here, and I'm going to write the formulas. All right, so dihydrogen monoxide. So my first element's hydrogen. How many do I have? Two, because of that prefix di. What's my next element? Oxygen. And how many do I have? One, because of mono. So that's a fancy name for water. So go home, tell your mom you want a glass of dihydrogen monoxide this afternoon. See what she says. All right, what about chlorine? How many chlorine do I have in this one? 1, Cl. How many fluorines? 3. ClF3. Wish we had more acid examples, but we'll get to those. All right, diphosphorus trioxide. How many phosphorus? 2. So di. So P2O3. Those are really easy. When you get the binary ones there that aren't acids, those should be really easy if you'll memorize the prefixes. All right, disulfur. So how many sulfurs do I have? 2. Decafluoride. Deca is what? 10. So S2F10. All right, here's an acid, carbonic acid. So if it's an IC, what was it previously? ATE. So if I look, I have carbonate. And carbonate is CO3. That's carbonate. CO3, and its charge is -2. It has a charge on it of -2. Now, if it's going to be an acid, what has to go with this carbonate? Hydrogen. What is hydrogen's charge? +1. Do those balance out to 0? No. So what do I need more of?
Another hydrogen.
I need another hydrogen. And so to make the formula for carbonic acid, I'm going to make H2 CO3, and that's gonna be my formula for carbonic acid. Any questions? No questions? Okay. All right, let me stop the video.